Math 2414, Power Series Video 2, first example. Determine for which values of x the following power series converges. In other words, find the domain of f of x. Okay, make sure the grammar was correct there. All right, so our function f of x is defined as the power series, the sum from n equals 0 to infinity of n factorial times x to the nth power. I do want to remind you that n factorial means the product of every integer from n down to 1. So n times n minus 1 times n minus 2 times ... all the way down to 3 times 2 times 1. And by definition, 0 factorial is equal to 1. So if you're not familiar with those two, you need to be familiar with them right now. Let's write out the first few terms of this series, just to see if we can get an intuitive idea of what may or may not happen. If we put in 0, we get 0 factorial, which is 1, times x to the 0, which is 1, under the premise that 0 to the 0 is defined to be 1. So we get 1 times 1, which is 1. If we put in n equals 1, we get 1 factorial times x to the first. Well, 1 factorial is just 1. X to the first is just x. If we put in 2, we get 2 factorial times x squared. But 2 factorial means 2 times 1, and 2 times 1 is just 2. So we get 2x squared. We put in 3, we get 3 factorial times x cubed. But 3 factorial means 3 times 2 times 1, and that's just equal to 6. Let's just write out one more. If we put in n equals 4, we get 4 factorial times x to the fourth. But 4 factorial means 4 times 3 times 2 times 1, which is 24. Or you could think of a factorial as just multiplying the previous answer times the next number. So we could just multiply the 6 times 4, and we would get 24. Now, these terms seem to be getting pretty large. And if you recall the test for divergence from previous videos, the only way a series can even possibly converge is if its nth term goes to 0. It doesn't guarantee convergence, but it's necessary. In this case, where is this series centered? Well, it's centered at whatever is being subtracted from the x before it's raised to a power. And since there's nothing being subtracted from the x, we can think of it as x minus 0 to the nth power. This is centered at 0. And keep in mind that a series always converges at its center. If we were to put in 0 here, we would get 1 plus 0 plus 2 times 0 squared, plus 6 times 0 cubed, plus ... And the tail end of the series would all be 0. The only thing that would survive would be 1. So we definitely get convergence at 0, but that's because every power series converges at its center. But will it converge anywhere else? I think it's pretty clear that it won't converge at x equals 1, because if we put in 1, we would get 1 plus 2 plus 6 plus 24. We would get a sum of factorials, and since those get larger and larger, the sum would diverge. So we already know it doesn't converge everywhere. But how do we find where it converges when we're looking beyond the center? And the answer is, and this is the technique that we will use for most, if not all, of our power series, to find where f of x converges, we're going to use the ratio test. If you're not familiar with the ratio test, then I highly recommend going to watch the second to last video in the previous series. But the ratio test basically said that a series will converge if the limit of the absolute value of the ratio of two consecutive terms converges if that limit is less than 1. If it's greater than 1, we get divergence. If it's equal to 1, it's inconclusive. So, sorry, my phone is dinging. All right, so how would the ratio test look here? In general, we would look at the following limit. The limit as n approaches infinity, and again, this is the general ratio test of the n plus first term to the nth term, that ratio, and we find out what that limit is. And if the limit is less than 1, then we get converges. If the limit is greater than 1, we get diverges. So this is just a summary of the ratio test. and if the limit is 1, it's inconclusive, and we would have to use a different test to determine convergence. So what would the ratio test look like on this one? Well, here's our series, our power series, if you will. And the ratio test, we would set up the limit as n approaches infinity of the ratio of the n plus first term to the nth term. The nth term is easy. You're looking at it right here. That's the one that goes in the bottom of the ratio test. For the n plus first term, you would just replace n with n plus 1. So we would have n plus 1 factorial times x to the n plus 1. And we look at that limit. So how do we do that? Well, first off, we need to think about the factorials. You will see a lot of ratios of factorials when you do the ratio test. So it's important to be able to play them out correctly. For example, n plus 1 factorial means n plus 1 times the number 1 less than that, which is n, times the number 1 less than that, which is n minus 1. And then you go all the way down to 3, 2, 1. And then the same thing with n factorial. It starts with n. The number 1 less than that is n minus 1, all the way down to 3, 2, and 1. When you take a ratio of consecutive factorials, you get a mass cancellation, and all you're left with, in this case, is n plus 1. So we know that the factorials reduce to n plus 1. And since the n is positive, there's no need to leave it inside the absolute value. Now, what happens to the x's? Well, the x's will, we can subtract the exponents. N plus 1 minus n is just 1. Now, we don't know if the x is positive or negative. We just know that there's 1 left. Because we don't know if it's positive or negative, we have to put it inside the absolute value. And now we have to look at this limit and figure out what happens. Well, remember the x's, it's the variable, but we're trying to ask for what x's does this converge. So in order for convergence, we need this limit to be less than 1 in accordance with the ratio test. So let's think about what x could be. We already know what happens when x equals 0. We already determined that because 0 was the center. It's erased, so I'm going to write it again. When we put in 0, we get 1. So we already know what happens if x is equal to 0. But what happens if x is not equal to 0? Well, first off, regardless of whether or not x is equal to 0, this x is independent of the limit, because the limit is saying what happens when n goes to infinity, but relative to n, the absolute value of x is like a constant. And because it's constant, we can factor it out of the limit and just ask ourselves what happens to this. Well, that's infinity. What happens to n plus 1 as n goes to infinity? You get infinity. So bending the rules a little bit and doing some infinity arithmetic, we have the absolute value of x times infinity. Now, we already know what happens when x equals 0. That was already determined. But what happens if x is not equal to 0? If x is not equal to 0, this equals infinity. And when I say this, oops, come back infinity. When I say this, I mean this expression here. And again, we're considering the case where x is not equal to 0. Well, what does this mean in the context of the ratio test? Well, infinity is clearly greater than 1. So our limit is greater than 1. It's infinite. So what does that mean? That means if x is not equal to 0, the series diverges. Therefore, f of x equals the sum of n equals 0 to infinity of n factorial times x to the n converges only when x is equal to 0. So in retrospect, it's a fairly uninteresting series because for the most part, it doesn't even converge. It only converges at a single value at x equals 0. We're going to look at some more series that converge at other places. And then after a few examples, we're going to make an observation and draw a conclusion. It'll become a theorem.